twisting and blowing through our world, making the seasons move and the landscapes change form. The wind and its restless gusts are nature's movers and shakers. Without wind, plants wouldn't spread their seeds so efficiently. Birds and insects would find it difficult to fly. Boats would have to lower their sails, relying only on paddles to make speed. And aircrafts, gliders and balloons wouldn't be able to glide across the skies. Most importantly, without wind, we would lose an important piece of our energy-secure future. How? That's a question of science. Kaithar in Tamil Nadu. Rows upon rows of wind turbines sprout up here like seedlings of a bumper crop. But this is no ordinary crop. Operated by the Center for Wind Energy Technology, this farm is growing the energy future of India. Experiments and findings here will help us move to an age where we will no longer depend on fossil fuels as a primary source of energy. Where the never-ending resource, wind, will be the key to clean and green energy. If the Center for Wind Energy Technology, or CWET, has anything to do with it, wind energy will have a big role in the coming years and decades.
In India, electricity generation is happening about 212 gigawatts today from all sources, and wind alone is about 19 gigawatts today is available. The potential is available at 50-meter level as per the official declaration, 49 gigawatts all over India.
Potentially, wind can steer India's energy fortunes in a big way. How can this be achieved? This answer lies in a more fundamental question. What is wind? We have all experienced the sensation of wind, either as a gentle breeze, a sudden gust, or the forceful push of stormy winds. And while we may not always be able to see it directly, it is felt and observed through its effects. Put simply, wind is the movement of air all around us. The next question is, what causes air to move? The short answer is differences in air pressure between two areas. You can do a simple experiment at home. Fill up a balloon. You'll feel that the confined air inside it has more pressure than the outside. When you release the air through the balloon's narrow opening, you will feel the strong gush of air rushing out to balance the pressures. The same thing happens on a much, much larger scale all over our planet and in our atmosphere. When the sun shines on the earth, it heats different parts differently. It hits the equator directly and heats it up more than the other regions. As this happens, the warmer, moist air rises up, creating a low-pressure area around the equator. Now, cooler air from other regions to the north and south rushes in to restore equilibrium. When this happens, wind is born. But this is just one factor leading to the birth of wind. The globe is affected by many different phenomena besides the sun's differential heating. The Earth's rotation and forces like evaporation and condensation contribute to unique wind patterns such as trade winds, the prevailing westerlies, and even India's lifeline, the monsoon winds. And that's not where the story of wind ends. Zoom in closer and you'll find more reasons for wind to blow, either gently or violently. coastal areas are affected by winds generated by differences in land and sea breezes. Even geological formations like mountains, valleys, and flat plains affect how wind blows. Mountain ranges like the Himalayas block cold winds from the north, while the Western Ghats fence in the wind, making the region to its east extremely windy. By now it's clear, wind is born not just due to one or two physical phenomena, but a highly complex set of atmospheric, oceanic, and geological reasons. At its gentlest, wind can erode solid rocks over centuries and millennia. At its strongest, it can rip through entire settlements in seconds, reaching stormy speeds that are faster than bullet trains. This immense power has had scientists in the last several decades asking, how can wind's energy be harnessed efficiently to generate electricity?
Wind is freely available, there is no cost for the fuel, and it need not be transported, and all the advantages are there. It is a green power, it will not emit any carbon emission. That is why wind energy is very attractive in a country like India, where we are depending on fossil fuels in a very, very great sense.
Helping India reduce its dependence on fossil fuels through wind is CWET. Its research facility is dedicated to developing wind technologies for the new age, including identifying the windiest parts of India in order to generate wind power. How do they do that? That's where the Wind Atlas comes in. Just like an ordinary atlas gives us a map of land masses, continents, countries, and oceans, a wind atlas gives us a complete view of how winds blow in different parts of the globe. It tells us the critical information needed to generate wind power, that is, wind speed and wind direction. But mapping the changeable winds of India is no easy task. From supercomputing to field measurements, it requires every resource imaginable. CWET's first job was to enlist the help of world-renowned wind energy experts from the Danish institute RISO DTU. These experts developed computer programs that mapped wind flow across the entire globe. Indian scientists collaborated with them to understand how these global weather patterns could be applied across India. Together, they developed a mesoscale model for India. But what does mesoscale model mean?
What we call as mesoscale model is based on weather models, large-scale circulations on the atmosphere, on any country. So, India being a big country, India was divided into 11 different zones.
Indian and Danish scientists studied global weather models. They then computed the complex weather data using parallel and supercomputing. The data described wind flow at a height of 1 to 2 kilometers above the surface. But that still wasn't enough information needed to set up a wind power station. Most wind turbines in India are not as high as 1 to 2 kilometers. At lower heights, where they are set up, like 100 meters, wind can behave quite differently indeed. This meant that the purely digitally computed wind atlas was still incomplete. CWET scientists would have to venture out into the field to fine-tune the measurements for lower altitudes.
We always believe measurement is reality. So, the measured quantity is the benchmark. The digital representation is a indicative wind potential at any location.
In the last decade, teams like these have erected measurement masts at 640 stations across India. The masts reach a height of 120 meters and can be lowered or raised to measure wind at 50, 80 or 100 meters. Each measurement mast is fitted with sophisticated wind instruments.
This is the actual typical model of the meteorological mast. It's a scaled down model. The model which contains the different instruments at a different level, which contains anemometer. The anemometer which measures what is the wind speed existing at the particular location, and this is called wind van, which measure the wind direction, which direction the wind which is blowing. And other instruments also we have it. This is called temperature sensor, which measure what is the temperature at the particular location, and this will measure the atmospheric pressure. So all this data are being logged into the data logger. So in wind industry we need every 10 minutes average of the wind speed. So this every 10 minutes average of wind speed is being stored in this storage device.
The full-scale masts are erected whenever there is a possibility of setting up a wind farm to generate electricity.
We are standing at the field, wind turbine test station. So now a wind mast is being installed. The mast which has different instruments, that wind anemometer, wind van, temperature sensor and pressure sensor. The data will be collected and it will be stored in the data logger. It will be analyzed at the office. This data will be used for verification of our wind atlas.
We have mast measurements up to 640 stations all over India, and these measurements typically runs for one continuous year and one covering all the seasons of the year. And these measurements give you the wind speed distribution in that height along with the direction distribution in the same place. And these two are essential for planning wind farm projects.
For any given test site, the mast collects data for 1 year over a 10-kilometer radius. All this data is then transmitted via GPRS to the head office in Chennai.
Google map which shows our Kaitar meteorological station mast, which is a 70-meter level, which has 5 levels of measurement. So each levels of measurement we can see here, this is actual real-time measurement, real-time data, that we can transfer real-time data from the site to our CWET office, our wind resource assessment unit. After that we can process the data.
Here, the massive meteorological information is computed to answer the question, how much wind energy will the selected site be able to generate? So, higher the wind speed, more the energy that can potentially be harnessed from a given site.
So now you give any latitude, longitude at any height, we will be able to give you the wind speed distribution and direction distribution, which are indicative anywhere in the India.
This information can be used readily by those who wish to set up wind farms. All they have to do is get their hands on the Indian Wind Atlas. Released in April 2010, the Indian Wind Atlas combines on-site measurements with digitally computed data to provide wind information for nearly 1,70,000 locations across India. It's given wind energy enthusiasts a clear idea of which regions are best to set up wind turbines.
Wind power distribution in India has been in the behind the Western Ghats, on the eastern side of the Western Ghats, the entire line, west coast line. The states like Tamil Nadu, Andhra Pradesh, Karnataka, Maharashtra, Gujarat, Rajasthan, all of them have excellent wind potential, because the wind behind the mountain, when it passes through mountain passes, gets an accelerated wind speed. That is why most wind potential areas are eastern side of the Western Ghats, not on the coast side. And these are the states, since the wind flows through all along through Himalayas, there are some more packets of other states as well, which may need exploration, and that will also have wind potential.
India is looking at a future where wind farms like these will dot our windiest regions. CWET is developing and testing wind turbine technologies to do just that. What's the basic concept of a wind turbine? Wind turbines are windmills that generate electricity. Windmills are tall towers. At their hub are a series of blades that encounter the wind. The wind flows over the blades, causing them to lift and turn. The blades are connected to a drive shaft that turns an electric generator to produce electricity. Depending on the location and its wind flow, turbines are differently designed. How tall should a mast be? What is the ideal shape for the blades? What kind of electric generator should be installed? These are all questions that can be answered by studying the Wind Atlas for any given site.
The Wind Atlas provides you, after release in 2010 April, at any given latitude longitude at 50 meter and 80 meter levels, it gives you wind speed distribution and direction distribution at almost 1,74,000 locations all over India, which is indicative potential, we call it, because we always believe measurement is reality. So, the measured quantity is the benchmark. The digital representation is a indicative wind potential at any location.
Besides being clean and green, wind energy can be an effective power source for many remote parts of India that aren't connected to the national or state electricity grid. Since wind turbines come in a variety of sizes and designs, they can be used for different purposes: industrial, small businesses, and even in homes. And while there is an initial cost to set up turbines, once erected, the power is free and unlimited. But there is one major drawback. Even in regions which the Wind Atlas deems suitable for wind farms, wind is unpredictable and changeable. Some days may be extremely windy, giving you a lot of power, but other days may not see anything but a light breeze. How can the unreliable wind be harnessed regularly? To resolve this problem, there are many wind turbine designs being developed across the world and in India. At CWET, engineers are developing turbines and generators that are not just low cost, but you and I can install them on our rooftops, even if the wind speed is not as high as at Kaiathar.
At Kaiathar Wind Turbine Test and Research Station, Center for Wind Energy Technology is conducting various types of type testing of small aero generators, which facilities available in India. It is a unique facilities available in India. Small capacity wind machines which can run very small wind speed, that means even with a velocity of 4 meter per second, this can be installed in any household with the household meeting the requirements of household, that is up to 5 kilowatt, 3 kilowatt, 1 kilowatt.
The challenge for wind technology is clear: to develop low-cost wind power systems that can extract the maximum energy from wind. In the last few decades, long strides have been taken by global scientists. As a result, countries like the United States of America have come to depend heavily on wind energy to meet their power needs. India is also on the same path to reduce dependency on fossil fuels using wind.
In spite of the ever-increasing cost of engineering materials, because of the technological advancements and large-size wind turbines and large towers and so on, the cost of electricity has, per unit of electricity generated from wind has come down from, say, 30 cents to 3 cents in US, or 30 rupees to 3 rupees today in India. So, this is a phenomenal achievement which has been possible because of the innovation that is taking place in this sector.
In India, as in the rest of the world, the field of wind power and related technologies is a new and exciting one. Technological advances like developing the Indian Wind Atlas put the power of the wind in individual users' hands. For India's dreams of an energy-secure future, the winds of change are definitely blowing our way. If you'd like to share your feedback on today's program, please send your suggestions and comments to Vigyan Prasar, C24 Qutub Institutional Area, New Delhi 110016, or you can mail us at info@vigyanprasar.gov.in.